Welcome everybody and welcome new viewers. My name is Michael with Archimede Design Company. I am going to do a Fusion 360 exercise today, and we are going to talk about sheet metal parts, designing sheet metal parts. This is a really basic bracket I designed for my truck, and really simple design in sheet metal. We're going to go through something actually a little bit more complicated than this. In kind of a real world scenario using basically a pressure gauge, a manifold, and pressure regulator. And we need to do a sheet metal plate for it so a plastic housing can attach over the top of that. So let's dive right in. All right, so what we have here is this design that I've already done. Basically what we have is we have some sort of manifold here that is attaching air inlets and outlets through a regulator and a regulator pressure gauge. There may be another gauge, of course, on the other side, so it shows the pressure coming in of a tank or etc. But this is just, an example of covering this part of it. And what this also has is there's a cover that goes over the top of it, and it has these little tabs here that are coming out to help kind of just engage it. So we have to make a part that can fit around these parts and be able to be this cap to attach to it. So that's what we're going to do today. As you can see, I've already come up with one, but we're going to go through this process to do one ourselves. So there are going to be some dimensions we need to know. We need to kind of know what the dimension is of this back part, so this can feed through. What the diameter of this pressure regulator is, the diameter of the screw holes and things of that nature. I've measured all that, so we'll start to put those things in parameters. And if you know me, I like to use parameters. Using parameters makes it easier for you to modify designs without actually having to dive into the actual drawings after the fact. Another nice, interesting aspect of parameters too, and even dimensioning in Fusion 360 is you can use equations. So we might use a little bit of that, but not a whole lot. So the first thing we're going to do is we're going to just define some parameters, but what I want to do is within this exercise, I'm going to create a new component. And I'm just going to make this part of the main sheet metal exercise. So here we have, and now we have that as our active component. That's mainly where we'll be working. So the first thing is under modify is we're going to do change parameters, and this is where I'm going to define parameters. If you've watched, I'll probably show it at the end, but I do have a parameters exercise designing a grommet you might want to watch. But one thing to keep in mind is after you start defining some dimensions in a design and you haven't parameterized it yet, you actually can go into the model parameters under this setting and start giving them names and defining them, and then physically changing them within here. So if you don't start out that way, you can start out, you can start to add them at a later time. So, but first, what we're going to do is we have several parameters that we need to define. I had to write a bunch down, but we'll get them in there as we go here. So we're going to add a parameter, and this parameter is going to be flange height. Flange height is going to be the actual height of one of the flanges on the sheet metal part, and it's going to be 1 inch. So we know our hardware. So the screws that are going to attach to that manifold are 1/4 inch screws. We're going to put 0.25. You say, hey, yeah, you need to oversize those. We'll account for that. But right now I'm just putting 0.25. And then another parameter is going to be the dial diameter. This dial diameter is a diameter that's needed to get that dial through there. And you saw that it was square. I actually made it round. You could kind of make it square, but it would have to attach differently in that case because it threads on, it has to screw. If it was square and it fit in there, then that manifold would have to be designed differently. So I just made it round. That is 0.80 inches. And the same with the regulator diameter. I measured that. 1.25 inches is enough for that to sit nice. Let's see here. The other thing we need to know is the height and width of those tabs that are going to lock into this. So the tab height is 1 inch. And the tab width is 0.18 inches. Other dimensions we kind of need to know, not necessarily need to know, and I could have defined, building the whole thing, I could have defined it, is the cover height is 7 inches, and the cover width is 4 inches. Now, the fact that I actually have the cover in my design already, I can use that cover to define the boundaries, and I don't necessarily need those. So we might go about it that way. I might actually use those. And then another parameter we'll need to define that's not necessarily in here, but it's going to be our sheet metal, the thickness of our sheet metal. So we'll get to that. As you know, the other thing I like to define is some sort of tolerance. So I'm going to call tolerance 32. That's going to be 1/32 of an inch. And then I'm going to add another one called tolerance 64, which is 1/64. Don't know how much I'm going to use these, but the always good to build in some sort of tolerance. In fact, I know where I will use it is in that hardware diameter. There are a couple other dimensions on just putting things in the right location. Won't define those right now, but we'll define them later. The next step will be to start kind of designing the patterns and things like that nature. And then also getting in and eventually defining the steel gauge. And the steel gauge in this case is going to be 16 gauge, roughly 0.06 inches. So we'll get to that point. All right, I'm going to turn off all of my extra stuff here. Except for this, and it's very faint on my screen, but this utility cover. It is clear, so it's even showing up even clearer than normal, but we're going to use that to define some of our boundary and understand where some of our features are at. So first thing that we're going to do is under here, we're going to create a new sketch. We're going to do it right at the boundary of the bottom part of this plastic cover, which happens to be at that axis. And instead of me now defining, like I said, the height and width of this box, I'm just going to actually create, project, intersect, solid model. I'm going to keep that link. And I'm going to grab those lines. So I've grabbed all those different lines that define the outline of this plastic cover. So we can actually then just turn this off so we can see what those are. So we've got that outline already. So that's good. We have some features that we need to define on this that we're going to be cutting out. One is where those tabs are going to be fitting in and where those holes are going to be at. So let's do the holes first. So right up from center, there's going to be a hole that is 1.25 inches. We define that as the dial diameter. And the distance above this, let's make sure our axis is showing so we can reference off of this. The distance is 1.25 above. Sorry, I said this is 1.25. Sorry, it was 1.25 above at 0.8 diameter. And then we're going to do another one below, which is going to be the regulator diameter, which is 1.125. And this is going to be 1.5 inches. Now you'll see that I still don't have a defined circle. This is because I can move this still right to left. I have to define it off this axis. One of the easiest ways to do that is just to create a reference line center to center from top to bottom. And then we're just going to make these collinear. And then we're going to do the same thing. There we go. So we have those lines defined. So we have a spot for our pressure dial and a spot for our regulator. Now it's the hardware locations, which are just right along here. Turn off the line type, make sure we have a regular line. Now you can do this as a point and a hole, however you want to do it, but since it's not a threaded feature, I just like to do a regular circle. So this is a hardware diameter, but plus one tolerance 32.281. And then again, same here. We're going to define the distance. This is from here. That distance is 1 inch. And just like the other one, we should put a reference line from center to center. And then we can make this collinear. And it'll be defined. The other hole could just make that, but what I'm going to do is I'm just going to mirror it. That way, if I change the diameter to that, it will change the other diameter in the right location. So I'm just going to save this. All right, so we have our holes defined. And we don't need these quite yet. We will get to those in a little bit. But the next thing we're going to do is the flange, defining this flange. So this is a unique feature. Profile right here, and that's the width of that intersection that was there. It's not necessarily the total width of the flange itself. If you remember when we did the tablet was 0.18 inches. If we inspect this, it's actually 0.1 inches because that's a narrower part. That's part of that flange, but the biggest width of that flange is actually 0.18 inches. And it goes 0.18 inches from this line out to here. But I need to have a little overlap for it to hook into. So we're actually just going to make a profile. Probably should not have that. And we're going to add 0.04 to it. And now 0.04 on both sides. This should be 0.018. So it'd be just tight enough to fit in there. And in fact, if we wanted to, we could add a little bit of a tolerance plus tall. Let's do 64. And I did not want this to be a reference line, so let's just change it back to not being a reference line. Now I have that, and I have this in all four corners. Nice thing is it's all symmetrical, so we can just take this and we can just do a symmetrical. So we defined all that geometry. The next part is we're going to create different flange geometry to actually create the flanges in the sheet metal part. Now we're going to need a new sketch. And this outside face from this side is where our utility box is. And our flanges are going to be down on the other side. So we need to create a profile from this direction and this direction and this other direction in order to create this. But before we do that, we want to go into sheet metal. And we are going to create a sketch while being in the sheet metal design space while we are in this component, the attach plate. So now we're going to do our geometry from here. So we're going to need to do a drawing that is, it can be right in this midplane. So let's start here. And we are going to do, those are reference lines. Okay, so let's do this. I'm going to go out to here, here, by, here's where I'm going to need it. Cover width divided by 2 plus overlap. And then we're going to do this up. And this is going to be flange height. And since I only did half of it, we're going to mirror it. So let's turn this off. Okay, so I've created a very basic profile, corners and all, no radiuses, nothing, with what that basic shape of the flange is going to be. But I'm not only going to bend this around 2 sides, I'm going to bend it around 4 sides. So we also need to finish this sketch. And if we bring this cover back in, you can see how this is going to create a sheet metal flange in this direction. Well, we also need to do one in this direction. So we're going to do a new sketch along here. And we're basically going to do the same thing. We're going to go from center up, and this is going to be cover height plus overlap. Oops, sorry, cover height divided by 2. Finish sketch. So here you can see I have 2 sketches. Usually when you're doing sheet metal, when you have a simple profile like that, you basically are just going to do that profile. You're going to extrude it. You can add hole features on the flat pattern or on the shape itself. You do have to keep in mind though, like even when flat pattern algorithms take into account a flat pattern, they will take into account stretching and things like that on where the part goes. So if you add your features to a flat part and then you bend it, those locations might change. So it's better to add the features to the bended part and then flat if you can. Some complex holes and geometry might have to be put in on the flat pattern. Like if you have a slot that you have, then you bend right in the middle of that slot. But here I have flanges in 2 directions, so you have to do both of those operations and then combine the part and then flatten it out. So we're still in the sheet metal part, and so the next thing is we would do is we're gonna create a flange. But we do also want to make sure that we have the right rules in place. And I'm going to just go to, well, we'll create this part just the way it is right now. So first thing is I'm going to create this profile, and you can do a chain. If you do chain, it's going to go to a certain point, try to do the whole thing. Now, once I have the profile selected, you can see that it has an arrow on both sides, and I'm gonna and there's a couple different settings you need to keep in mind. We're not going to talk about lofting edges at this point, but just straight up just doing sheet metal. So one is the distance. So you can define the distance in which you want to pull this part, and you can see it automatically creates the radius. It automatically creates the thickness. And we haven't set those settings yet, but it's defaulting to just the regular default rule and the distance. But just like any solid model, you can also do it on 1 side, 2 sides, or symmetric. We're going to actually do it symmetric, and we want to do it that total distance of our cover width plus the overlap. So I put that in, and then we can actually put that definition in here. Cover width plus overlap. And I do need to divide this by 2 again. Unlike in the solid model thing where you can do a solid model, it's symmetric and you can define whether it's the extent or on each side. This does just symmetrical the total width. We are going to create a new body at this point in time. And here you see the sheet metal rules. And there's different rules in here that are defaults. Steel, stainless steel, aluminum, steel, inches, millimeters or inches. I have a predefined steel 16 gauge that we can pick. So 16 gauge, you can see how the thickness of this changed. If I go back, let's go to steel inches. You'll see it gets, so it's thinner, which that's what we want. You can also override the bend radius. I don't know why it's in millimeters when I pick an inch setting, but you can type that in inches. There is a place we'll get to, I'll show you, where you can define your own things. Now I will say this, I haven't figured it out yet. These rules are per drawing, they're not per the system, so you probably have to go into a library or somewhere to define the actual gauges that will show up all the time in all of your drawings. So this is specific to this one. Okay. So once we did that, you'll see down here in the browser, it created a rule called 16 gauge. And if we click on this, we can switch this rule to any one of these rules right on the fly. So if you want to modify the sheet metal rules, we can go to modify and click up here, up right next to the fillet. And here's where you see what's in the design, what's in the library. And you can literally go to any one of these that's in the library, and let's say steel inches. And you can say, this is my thickness, this is my K factor, and then just leave thickness the way it is. I usually put the name of 16 gauge or something in here. You can give different bend radius and settings and ways that you want to do that. I don't normally touch these. There are books on sheet metal where you can get the K factor that you need and the recommended one of these. But for now, for what we're doing, I think it's fine. That's how you change it and create your custom rule. Now we need to do the other profile. We're going to do the same thing. We're going to do this time cover height. I just realized that I have a problem here. So what's going to happen? Well, you know what? I'll actually show it so you see it, because you obviously can't bend things into really close corners. So let's just do this just so you see what I'm talking about. So let's do cover height. Still gonna just do a new body. So you'll see how close this is. We're actually gonna merge these together, but we actually have to create offsets to this a little bit so they don't meet exactly in the middle. So we have to leave room in there. So let's change our sketches, our not necessarily our sketches, but the distance that we pull those flanges. So down here in the history, we're just going to right click and edit this feature. And we'll get rid of the overlap part, because we did take account for the overlap we needed when we defined these flanges. And then let's do the same thing with this one. We're going to get rid of the overlap. Nice. Okay. In fact, if we want to even give it a little bit more, we can do It's tall 32. And the same thing. Tall 32. Okay. Right, so now we have two bodies that are, as you can see, sheet metal parts. So if we combine those, and now under the modified, there is no combine here. You actually have to go back to solid model and go to combine. We want to combine them. We do not need to keep both bodies, so we're just going to not keep tools. And so now it's created a single body. That is still a sheet metal part. I would like to, now we're going to do some modification just to putting in the holes and everything that we need. So first thing is we're going to put a couple chamfers in here. Now we still have this other sketch. We're still in sheet metal. We're going to extrude. And let's go to the back side here. All of our holes. Let's remove our body for now so we can see what we're picking. We want to get all of this. So here we have basically our part. Before we do the flat pattern of it, let's just give it some color, physical material. I do recommend that if you know what metal you're going to be using. I'm picking metal, and it's going to be steel. I don't know what kind of steel, so we'll just do steel. Drop that on there. Close, and then let's say we're going to paint it. The appearance, and instead of the red like I did before, here you can just do different textures and things like that. But let's say we're going to make this green. Or maybe it's a regulator for oxygen. I don't know. So one of the other things you want to look at really closely too is this setting where it says side 1, side 2, or center. This is defining on what side is it going to put the material. Is it going to put it on, side 1, which is like the top side, or side 2, bottom side, or is it going to center over the 2? So as an example here, if we select side 1, and if we look at, you can see that side 1 actually is pushing up into the cap. That's not really that overly important because this cap moves back out of the way. It's not like a solid piece. I'm not building it into anything. But you can see if I select side 2, it pushes it down on the other side. If I do center, it's going to make it symmetric. So if we go with side 2, it's going to do this. And then make sure they're both side 2s. So let's just bring in our other components and see how things line up. So we have our cover. We have we won't do this attach plate, that's the old one. We have our regulator, collar, hardware. And let's just turn this one on. So here we have our cover. Everything seems to line up. You can see here where this is wide enough for it to get in, but there's a little bit of overhang for it to grab. Could we, make it a little bit smaller? Possibly. Should be enough though. Want to just squeeze it a little bit just to get it to pop up. Next thing is we want to create a flat pattern of it. So basically, once you're in active, we're active in here, active in this body, and we are going to do flatten. It's going to say select the face that we want to be stationary. So this is the face that's face down on, like, imagine the sheet of metal. It's the face down part. You want to be face down. That's this face. Do OK. And it's going to create this pattern. So here you can see where the radius is in, where the center bend line is, where the holes are at. You can see we avoided getting right into the bend right there. You might get a little bend on that corner. Should be okay. We'll actually narrow it a little bit, which we would probably like. So, you'll do a drawing and you'll want to define the thickness of the material, the type of the material, the finish, if there's any, not necessarily finishing at that point, if there's any processing that gets done afterwards prior to it. But you will need to say that this is this radius bend 90 degrees, because you can do bends. We could have made those flanges instead of 90 degrees, maybe we made them 85 degrees or something like that. So, and then you'd have that kind of bend. But that's your basic flat pattern, and I will give a link to an organization where you can actually just send them a step file of a sheet metal part. And it will flatten it out for you, and you can say how you want it finished, and they will cut them out and send them to you. It's a really nice organization. There's a few of them out there, so maybe I'll try to hunt down a few of them. Yeah, so that's really the basics of creating a flat pattern sheet metal design in Fusion 360. And especially doing it around the design of other components. I'll give you some examples of these components: the compressor, regulator, the dial, the fasteners, all of those parts. I got those all at McMaster-Carr, which, in fact, you can actually import directly from McMaster-Carr into Fusion 360. You can also get files from other sites and then import them. They have some other part companies that they can work with. And then I actually went around and I physically actually designed this manifold myself to fit into these. So using these as references for the design. So yeah, that's sheet metal design. If you have any questions or comments, comment below, and please like this video and subscribe, and be on the lookout for future videos. So have a great day.